In this video, we're going to go over the standard, what is called library of functions. Basically, it's a group of functions that comes up very often in our algebra classes, and we pretty much expect you to know what they are and what the graphs look like. There are more functions than just the ones in this video. We will see more of them in future videos, but for right now, this is a good starting point just to get a good familiarity with these functions here. The first one is f of x equal to x. There is a special name for this. It's called the identity function. It says that the output is the same as the input. On the other hand, it's also a linear function, and it's going to have a slope of 1 and a y-intercept of 0. So it's going to look something like this. And based on this graph, the domain is all the way negative infinity, positive infinity, and the range is also negative infinity to positive infinity. So this first one is just the standard straight line there. It's at 45-degree angle if you want to look at that perspective. The second function here is f of x equals x squared. This is, a quadratic function, the graph of which is going to be a parabola. And it's a parabola that is going through the origin here. It looks something like that. Obviously, it shouldn't be a little squiggly like that. It's just because I didn't draw it as carefully as I could have. For this one, the domain is still going to be negative infinity to positive infinity. But the range, the y values, they can't be anything. You're only going to get y values from 0 on up to positive infinity. Okay. Next one here is f of x is x cubed. This is a cubic function. It's going to look something like this. Goes all the way up and to the right and down to the left, kind of like the line, but it is curvy here. It is going to have a domain of all reals and a range of all reals. This one doesn't come up quite as often, but it's good to see differences between degree 1, degree 2, and degree 3 graphs here. Then we're going to go to ones that are not just polynomials. This one here is f of x squared of x, the square root function. It's going to look something like this here. In fact, I'm going to redraw that out because I don't feel I did a good enough job there. It's a little bit more tapered off here. This one's going to have a domain only starting at 0, and similarly a range only starting at 0. On the other hand, when you get to the cube root graph, this is going to work the same for any odd root, so fifth root and so on. It's actually going to have negative parts as well as positive parts. It's going to look something like that. And our domain is negative infinity, positive infinity. And our range is negative infinity, positive infinity. Then we're going to go away from the radicals here and get an absolute value. Absolute value is basically the V shape here with a nice crisp point at the origin. This one will have a domain, negative infinity, positive infinity, and a range of 0 to infinity. Then we're going to get some rational functions, these fractions here. 1 over x is going to look something like this, and you have two separate pieces. It's actually the first of the graphs that we have here that has two separate pieces. There is something about that you'll care about in future sections, but for right now, it's got two different parts here. The domain is x can be anything other than 0, which you could write down in interval notation as follows, but it's kind of more hassle than it's worth. And the range, it would look the same for interval, but in this case it's saying that y cannot be 0. Y can be anything other than 0 here. On the other hand, when we have 1 over x squared, it's still two pieces, but this time the two pieces are both above the x-axis. You have the same domain, but this time your range is every number that is bigger than 0. I do want to call a little bit of attention here. This range has parentheses 0 to infinity, whereas all the previous ones had bracket 0 to infinity because 0 was a possibility there. On the 1 over x squared graph, 0 is not a possibility to get out. All right. And the last one here is f of x is just some number c. That's just going to be a flat line here at the particular y value c. These are called constant functions. And the domain will be all reals here. But the range is kind of an interesting thing because the range is only one possible y value. So you can't really write it nicely in an interval notation. So we use the curly brackets to indicate just the single number c is the only possible output. And this is what we have. Now again, all of my graphs here are not great because they're done by hand. And when you're drawing them by hand, I understand yours are not going to be perfect either. Although I would not be surprised if a lot of you could do it more accurately than I can here. But the main thing is we just want to get an idea for what these look like. We don't have to have perfect graphs here. We have computer software that can give us a more accurate graph if we really need it. But this is what we have. You really want to know all of these functions and the basic shapes of how they look.